Well, thank you everyone for joining. Today, I would love to introduce Peter McKee. Well, I'm going to be very brief, but Peter McKee is a developer, advocate for Docker, and maintainer of the open source project Ronin.js. He is originally from Pittsburgh, Pennsylvania, or PA, but currently in Austin, Texas. And Peter has built his career developing full stack applications for over 25 years. He has held multiple roles, but loves and enjoys teaching and mentoring the most. Now I'm going to pass it over to Peter to get everyone started with this workshop.
Yeah, it helps to unmute. Sign of these times. Anyways, hello everybody. Hope everybody's doing good. Um, Again, my name is Peter McKee, and I work for Docker. I'm head of developer relations and advocacy. I've been at Docker probably about coming up on 4 years. I just moved into the developer relations role. Before that, I was senior software engineering manager. I ran all of the customer success tech. So all of we had a knowledge base and training materials and a bunch of tools internally. And then the public knowledge base and our enterprise support kind of tool. And then I left for a bit when Docker sold the enterprise product about a year ago. And I went over with that company for about 2 months and then came back. So I've been back here at Docker for 10, 11 months, something like that. Love it here. But yeah, thank you all for attending. I really appreciate it. I can see that everybody has turned off their cameras. No problem. If you would like, turn on your camera. Totally cool. If you want to ask a question as we kind of go through, feel free to just jump in. I believe you can also, down in the reactions on Zoom. Oh no, I thought there was a hand, be able to raise your hand. But anyways, just get my attention, ask me a question. If it's too long or too in depth or maybe a little bit off topic, we can save it to the end. I'll try and give maybe a quick answer and then we can save it to the end. But let's see. So let me go ahead and jump into it. Let me share my screen. Okay, hopefully everybody can see that. If you can't, holler. But I'm going to move you guys out of the way. Move all the Zoom controls out of the way. Okay, so today we're going to talk about Docker and containerizing machine learning workflows. Let me just start off by saying that I am not a machine learning expert. I'm not an AI expert. I'm not a deep learning, all those things. I know it okay, right? Enough to speak about it, but I know Docker really well. So today we're going to kind of talk about how to put those type of things inside of containers and how to use containers and kind of how to think about it. And so I'll start off with an overview of Docker, why Docker, basically what Docker is, why you should use Docker, think about using Docker. And then we'll roll into some labs, hands-on labs. I'll provide a link where you can download the labs from GitHub. You can walk through it. What I'm thinking about is I think there's about 10 of us, 10 of you, I should say. There might be more. But what I'd like to do is move everybody into, oh, wow. Okay, there we go. Move everybody into some breakout rooms, maybe 2 or 3 people in a room. You can work independently while you're in the breakout room, but then you also have each other to kind of talk to. I know when I do labs or when I'm working through some training and tutorial materials, typically sitting in a classroom, you have your classmates to talk to. So this way, if we put you in breakout rooms, you can talk to each other. You can ask questions if you get stuck. Sometimes it's just you typed in the command wrong or something like that. But also, if you're in the breakout rooms, I will still be here. I know in the breakout rooms, you can raise your hand. I can join the breakout room and help if anybody's stuck or answer questions, those type of things. And we'll do each lab probably 15, 20 minutes. They're pretty short labs. 2 of them are probably decent, maybe a little bit longer, but I don't think you should have any problems. If you do, again, raise your hand. At the end of the time, I'll bring everybody back. And then you also have access to this material afterwards, so you can go through it again. But yeah, so that's the plan today. it keeps jumping ahead on me. Okay, sorry. So little introduction to Docker. So actually, this prerequisite should be there. I don't know how it got in out of order, but anyways, so prerequisites. So you need Docker installed on your machine. So grab Docker desktop. You can go to that URL. Um, then choose your platform, whether you're a Mac or Windows, or if you're running Linux, it's totally fine. You don't need desktop, but you do need Docker running locally. If you don't have Docker locally and you can't get it installed for some reason, you don't have local admin permissions or something like that. We have Play with Docker that you could use, or we can spin up an EC2 instance. You can use those. But so anyway, so download Docker, get it installed. It's very simple to get installed. That Docker desktop includes everything, includes the CLI, the engine, everything is installed. You'll have everything you'll need. The other prerequisites is a Docker ID, a hub account. It's free. We're going to be pushing some images in the hub, pulling them down. Nothing too major, but it's a free account. So go ahead and sign up. I think we asked for your go into hub. We asked for an email, Docker ID, and an email. Do that, sign up, and that way we can you can push your images into the repository. Okay, any questions there so far? Everybody have Docker installed? If you have any comments, concerns, questions around that, you can also just put it into the chat. And let me pull up the chat, make sure I can see the chats. Zoom is always interesting when you're presenting. Forgive me here. I just want to make sure I have chat up. Okay. Just so I can see. Okay, we look good there. Okay, sorry about that. Just want to make sure someone wasn't asking a question in chat while I'm talking. Okay, so those are prerequisites. I'm going to jump back a slide here. So let's talk a little bit about Docker. So Docker is an open platform for developing, shipping, and running applications. So basically, Docker started out as an open source project. It came from .cloud, which was a platform, was a cloud service where you could kind of like DigitalOcean, Amazon, GCP, those type of things. And they were using containerization under the hood, and they had built some tools to start containers, stop containers, kind of run applications as isolation and be able to scale them. And they said, oh, this is pretty cool. This is pretty easy. So why don't we go ahead and provide these tools as open source? So they packaged them up into Docker, and then .cloud eventually became Docker. And now, 5 years later, it's also a company that's trying to make money. So we're building a platform out, focusing on developers. We have Hub, which is kind of the de facto image repository. So on Hub, you can find official images. They're scanned by a partner of ours called Sneak, does security scanning. You can store your images there, private and publicly. You can create teams, you can share images, and you can set up auto builds, auto testing, kind of a CI pipeline. And then on the other side of that, we have the Docker engine and CLI. So Docker is architected in a client server. So we have the Docker engine that runs as a daemon on your machine, and it listens for commands on an API. And the CLI talks to the engine through an API, tells it to start containers, stop containers, build images, download images, those type of things. And so there's a lot of confusion when people first come to containers. What's the difference between VMs and containers? So VMs are, and I have a good image here. This is out of our docs. And I had this confusion when I started working with containers. I didn't understand it. Didn't make sense to me. I saw a demo and people said, oh, well, you can deploy your applications easily and they run in an isolated system. And it sounded a lot like a virtual machine to me. And so if you look at the way virtual machines are architected over here on your right, if you're looking at the screen, we have the infrastructure at the bottom, so bare metal. So the computer, the compute, the CPU, memory, those type of things. And then you have what's called a hypervisor, which is allows you to do a virtual machine, allows the hardware to be virtualized. So things running above that to an operating system, it looks like it's the only operating system running on the machine, and it thinks it has access to all of the hardware. And then within that guest OS, so let's say we installed Windows, Linux, Mac, whatever you want to install on there, that full instance of that operating system is running on that machine. And then you have your libraries and binaries, and then your applications on top of that. And to run multiple applications, if you want to run them in a single VM, you have to install multiple VMs, which is multiple operating systems. Where conversely, with containers, and containers is not a new technology, right? Old Unix systems had a lot of operating system constructs where you could isolate processes and those type of things. And the constructs that are underneath Docker, C groups and namespaces and those type of things were around in Linux for a little bit. But what Docker did is made it very simple to use. And so the difference between a VM and containers, as you'll see in this this image on the left, is you have still have your hardware, of course, your infrastructure, so your CPU, your memory, those type of things. And then you have the host OS. So whether it's Windows or Linux, primarily Linux is running. So you have one operating system running. And then Docker sits on top of that with the daemon. And then within Docker, what Docker does is it can isolate a single process and allows that process to think it's the only process running on the system, isolates it to what other processes it can see on the system, what other resources it can see on the system, whether that's CPU, memory, networking, those type of things. And inside of that container, you share the operating system. So there's only one OS running. So a lot of times you have, I'll get the question, can I run Windows containers on Linux? You can't, because containers share the operating system, the underlying operating system. So they each share Linux underneath. And if it's a Windows container, they each share Windows. The way you would run a Windows container on a Linux system, and it's not really running on there because you would use a VM. So you create a VM and then run Windows inside of there. So you're really running two Docker instances. That Docker instance would run inside that VM. But containers are just basically a process, a normal operating system process that's been isolated and encapsulated using Linux OS constructs. And so when you have multiple applications, they're lightweight, they're a single process, and they all share the operating system underneath. So they're fast, so there's a issue of speed. And really, it's a normal process that runs just like any other process on your operating system. So speed is really not an issue. Any questions there? Okay, it looks like Angie. Okay, so I'll wrap up this introduction and then let me reach out to Angie and I'll help you get Docker set up. If we can't get it set up, we'll use Play with Docker. Okay, great. So Angie was just asking, she was saying she can install Docker Desktop on her machine. Not a problem. We'll figure it out. Okay. And I talked a little bit about this already. So Docker runs packages, Docker packages and runs applications in isolation. So there's security constructs using C groups and namespaces and those type of things. And it's not very important right now to understand how those work. The biggest thing to understand about containers is that they're basically a process and they're isolated running on the system. And basically a process is made up of your exe, if you're on Windows, or your executable, a binary on Linux. And then all the other configuration, supporting libraries, all those type of things are inside of that package. And inside the package, when I say package, I mean image. And so inside of that image is basically a file structure. And that file structure, you can copy any files that you want into that file structure. And then that file structure is taken and wrapped up and put into an image. And we're going to walk through that in the first lab here. So why use Docker? So especially for ML. Um, so one of the main reasons is you can provide portable training environments. So it's super easy to put everything into an image, wrap that up in an image, share it up onto the hub, and then coworkers, colleagues, people in the community can then pull down your image and run it locally and have everything they need exactly the same as you had on your machine. And there's a couple different ways you can do that. We'll talk about that in a second. And so that makes it easy to deploy not only to coworkers or colleagues in the industry, but also into other runtime systems not on your machine. So into the public cloud or the private cloud. And we're going to look at that running things in Amazon. Um, so what should you put inside of your container? Two main ways you can look at it. There's obviously you can do it a million different ways, of course, and I would suggest once you get more familiar with Docker and containers, and as you're sharing your images and your data sets and those type of things, think about how you want to do that. But the two main ways to do that is to put everything inside of an image. So all of your frameworks, your runtimes, your dependencies, your data models, your code, all that, put that all inside of an image. So then when I share that with you, you have everything you need inside of that image. The other way to do it is to just kind of wrap up your working environment. So wrapping up your frameworks, so PyTorch and those type of things, and then the dependencies it needs to run. And you can wrap that in an image. And so you have the same exact versions that you need to run that data that your code needs to run. And you package that up and then you can share that. So you have an image with specific versions of an environment that you want to share. And then once you share that image, when you run it, you can then include inside of that container the code and the data sets you want that you can manipulate and work on. And we're going to look at two of those scenarios both of those scenarios in the lab. Right. Yeah, David. What should you share in a container? Your code and your data, enough to get a container service up. Yeah. So I kind of just talked about that. Hopefully that answered your question. Like all great questions, good answers start with it depends. So it really depends on what you're trying to achieve. So if you're doing some kind of if you're sharing out with a coworker or out into the industry, and you want them to have everything they need to reproduce what you've done, that's when I would put everything inside of an image. Um, and then if you're kind of just working on environments, let's say you're working in a lab with other folks, and you just want to containerize that environment that everybody's working on, you can put that in an image and share that image out. So folks can download that image. They have their code and their data locally, and then they can include that into the container when it's run. Yeah, your own data, sample data, any kind of data, really, David. David asked, what kind of data are you talking about? Okay, cool. So those are two main ways. There's obviously different ways you can do it. You can create an image that at startup, it downloads data and then runs. And we look at a scenario in that. But yeah, multiple ways you can do it. So, um, so, and two ways you can create images or share your images or containers. And please forgive me, a lot of times I use images and containers synonymously, but they're not. But when I'm talking generally, I'll use containers or images. So if at any time I confuse on when I say image when I should have meant container, please ask. But generally speaking, you can talk about them as the same. But technically speaking, an image is you can think of it as in object-oriented programming, or let me do an even different analogy. So you can think of it as a cookie cutter. So if you're baking, right, you have a template, which is the shape of your cookie you want to make. And we're coming up here on into the holiday. So let's say it's a Christmas tree or it's a reindeer or something like that. You can have a template of a cookie of a reindeer, and then you can use that template to punch out cookies. images and containers are the same. So an image is basically a template. It's a template for running a container. So in an image, you have everything bundled up, like I said before. So your executable, your runtime, your libraries, your data, your code, anything you need to run. And then that image could then be run multiple times. So you can run an image inside of a container multiple times. So think of a container containerizes an image and runs it. And an image is a template for a container, to start a container. So you can create your image in one of those two ways we were talked about earlier, and you can share that on Hub or other public repos. And then I can pull down your image and I can use it. Or I can create a Docker file, which is basically the directions on how to create an image. And so I can grab your Docker file off a code repo, let's say GitHub, and I can execute that Docker file and recreate the image and then run that image. So those are the two main ways. Okay. Any questions? Let me check in the chat. If I'm rubbing my hands, forgive me. It is freezing here in Texas. At least for us, it's cold here. I know in Toronto, it's probably a lot colder, but down here in the middle of Texas, it's probably in the 40s, which is absolutely freezing for us. So forgive me. Let me see. Let me look in the chat real quick before we get started. Enrique, I'll let you go through some of these labs and then let me see if you get an answer to that question. So Enrique asked, we use Anaconda and create the environment using YAML that has a list of packages needed for the model. What would be the benefits to moving to Docker? So the benefits would be to be able to containerize all of that and then share that. Instead of using local environments and those type of things. You could still do it, absolutely. It's just moving what you're doing with Anaconda into a Docker file and setting all of that inside of an image. And again, the difference between doing that locally when you run a process on your machine, that process is exactly the same. It's just running inside of a container, and you can restrict what access that process, what resources that process has access to. Hopefully that makes sense. Okay. Okay, great. I'm going to come back to the security one in a minute, but let's get started. Let's get everybody started, and then I can come back to some of these questions. They're great questions. Okay, awesome. So labs, everybody, if you would, please go to this repo. You can either just click on, I think this will land you right into the root of it, and then the content is there, content folder. So if you go in there, they're listed by number. So 01 would be the first. And that'll be introduction to Docker. And so before everybody gets started, does everybody able to get in GitHub, see where that's at? Let me know if you're having a problem seeing how to see the labs. If not, let me see how many folks are actually here and if we want to do some breakout rooms. For those of you that joined a tiny bit late, I think I'm going to do, let's see here. So we got about 18 of us. So if we did, I'm going to create some breakout rooms. I'll put 3 of you each into a breakout room. That way you can go through the labs together. You can ask each other questions. If you have a problem, raise your hand in the breakout room and I will come in and join you. Okay, cool. Let me stop sharing. And now, okay, where did it go? Okay, I don't think we have breakout rooms, might not be enabled. Okay, no worries. All right, so everybody grab the labs, start on lab 1, please go down through it. Just ask questions here in chat. You can send them also to me directly, or I'll be here, I'll be hanging out. So just unmute yourself, yell at me, say, hey, Peter, I have a question, no problem. But if not, if it looks like everybody is muted, awesome. If not, please mute yourself just so in case some of you have some nice keyboards and we hear some typing and or if you're talking or whatever. Um, awesome. So go ahead and jump into it. We'll give you, let's do about 15 minutes. So let's see. I want to make sure we have enough time. So we got about an hour. Yeah, let's do 15 minutes. So at 10:45, I'll come back on and holler at everybody and say, hey, come on back in. But if you have any questions, just reach out. Okay. Any questions? Yeah, David, that'd be great if you want to help. Angie, was it Angie? Yeah. Okay. Oh, you sent that to me. Uh, okay. Angie, are you still here? Yeah. Let's see how we can do this. So everybody go ahead and get started. Let me see, Angie. Let me see if I can get you not into a waiting room. Angie, I will privately, I'll privately chat with you, okay? Looks like we might have had some folks just joining. For those of you just joining, we're just going through the first lab. I'm going to finish up here in maybe 5 minutes or so. But let me put the link in the chat is the link to the GitHub repo. If you navigate there, inside of the content folder, you'll find the lab. So if you start with lab 1, introduction to Docker. Okay, how's it going for everybody? Anybody need more time? Anybody have any problems? Want to make sure everybody got kind of the basic Docker whirlwind tour. Let me know if you have any questions, but I'm going to go ahead and move on just for the sake of time. And then just send me a chat if you have any questions or anything. Okay, awesome. So the next thing I want to take a look at, I have a couple slides, but they're not important. So sorry. Okay, losing screens there for a second. Okay, so the next thing I want to take a look at is containerizing your Jupyter notebooks. So again, I'm not a data scientist or work in AI or anything a lot more fun and interesting that you folks do. So I'm not an expert in Jupyter notebooks. So to build data models and those type of things in, but we found that talking to some of our customers that containerizing their Jupyter notebook environments is very helpful. So in this next lab, we'll do just that. We'll containerize a Jupyter notebook and then connect to it outside of the container working locally. We'll do this locally, but it is extremely easy to run a container up in the cloud and then connect to it from your local machine. So if you don't have a very powerful laptop, you can spin up a nice beefy EC2 instance, have GPUs and those type of things attached, and then expose the port from the Jupyter notebook publicly, and then you could add a password and token and those type of things, and then connect to it from your laptop, and basically use your laptop as a terminal and use the Jupyter notebook up on a big, nice beefy machine. So anyway, so it's about 10 till. So let's go ahead and do that. So go back into the GitHub, go into the second module and just follow along. Again, if you have any questions, virtually reach out your hand either with, I believe there's somewhere in Zoom. And while you guys are working, I'll go look up exactly where to raise your hand. I've never done a workshop in Zoom, so forgive me. But also feel free to just chat. I almost said Slack. You can Slack me privately. Just go ahead and chat me privately if you have a question or having problems. But yeah, go ahead and move on to the second lab by containerizing or Dockerizing your Jupyter notebooks. All right. And we'll do that. We'll do about 10 minutes. Okay. It's a small lab. if you've not done it before, it might take you the whole time. But anyways, we'll do about 10 minutes. It's not super difficult. Just for, again, for the sake of time, I want to definitely get into the next lab and have the most time for that. Okay, awesome. Have at it. Let me know if you have any questions. Okay, folks. Looks like a couple of you are having problems pushing to hub from the last lab, from the first one. You need to number one, you need to log in, so you need a Docker ID, and you can just do Docker login dash username, and then it'll ask you for your password. That should log you in, and then you should be able to push. Also, to another issue when pushing, sometimes you might not have the image built locally. If it tells you it doesn't have the image, to push an image into Hub, you need to put your Docker ID in front of the image name. So my Docker ID is P McKee. So I do a Docker tag. So I tag that image and I put P McKee / I think it's my hello, or I believe the image name was something like that. Once you tag it with the repo, then Docker Hub knows where to put it. The other issue that others might be seeing, doing the Docker Jupyter image, trying to run that locally. If you try and run it and it says it can't find the image, that means it's not local on your machine. So since it's not on Hub, since we're building that locally, you have to build it. So we do a Docker build. I think it's -t to tag it. And then I believe we're using a separate Docker file. So do a -f space Docker file .jupyter, I believe. And then another space and then a dot to tell it what context you want to build in. And that will build the image, then you can run it. Okay, great. Okay, I'll be right back to the chat. Sorry, I had another question. Okay, cool. So let's move on. So we're going to move on to the next lab, which is Dockerizing training models. So the lab is fairly long, not super complicated, pretty basic. The code I've used actually got it off of PyTorch. It's one of their tutorials. So what found just a sample set of Python code using PyTorch to build some models and train it and then test it. So that's all inside of that. And the module walks you through setting that all up. So if you have a problem setting it up, please reach out to me. But let's go ahead and move on to module 3. That's the meat of it here. And we're going to give, I'm going to do 20 minutes for this. So the last one we'll probably run out of time. Maybe you can do it on your own at home, but go ahead and jump into module 3 and run through that. Again, let me know if you have any questions. Probably the best way is just to chat me privately. Awesome. Okay. Also, some folks are having some issues running some images, so I might talk to them. There's no way I can get to them one-on-one, so might have them share their screen in here, and we're going to be talking. So forgive me if we're talking. Maybe you can mute your speakers or something while we're talking, so we don't distract you. But okay, great. Okay, so am I still muted? No. So Jeff, are you having? Yeah, Jeff, use Play with Docker. That should be fine. That's a lab, same environment that you'll have locally. Don't worry about messing around with Windows for right now and groups and all that good stuff. Someone else was having an issue. Forgive me. This is the Zoom chat is a nightmare. Everybody's just jammed into the Zoom chat. Okay. Yes, Leonardo. Then do a Docker push your username / my hello. There you go. Yep, you have to tag it first, and then you can push it, Leonardo. Okay, yeah, yes, forgive me if I'm pronouncing that wrong, but yes, it's not a pre-built image. So we're building it first, correct? Okay. Whoever needs some help and you want to share your screen, we could take a look at it. And If not, I'm going to go back on mute. All right, guys. Thank you. All right, everybody. It's 25 after. So hopefully you were able to get through that that lab. I know it was a little bit long. I don't think we're going to jump into the last lab, but definitely just because of time, we're ending here in a couple minutes. I wanted to leave some time for some questions. Um, but that's a public repo. Feel free to grab it. At the end of this, let's say by the end of today, I will take the finished code repo that you've been kind of building and working on, and I'll push that up into the public repo. So you not only have the labs, but you also have the kind of the answers. Um, so yeah, so anybody have any questions? Feel free to unmute yourself and fire away, and we'll see what I can do. I'll take a sip of my water while y'all think a little bit. I'm sure there's some of you still typing away. No? Okay. If you think of something, here, well, let me share. Let me share my screen. So thank you, everybody. I really appreciate you coming, showing up, going through the labs and the tutorials. Two places where you can reach out. So go through it, finish it. I know this was very quick. Two places that you can find us. Probably the best is if you're not in our community Slack, check out Docker Community on our website. Get connected into the community. I run. We do a couple. We're starting doing a couple meetups this month. Actually, right after this, I'm kicking off a getting started with Docker workshop. And then in a couple weeks, we're going to do a series called "I Didn't Know I Could Do That with Docker." And we'll be doing some machine learning stuff. We'll be doing all kinds of different things. We'll probably do one on connecting into using GPUs in the cloud. So sign up, go to Docker community, get into the community Slack, get on our newsletter. That's the best way to find out what more information is coming out. Also, you can follow me on Twitter at PMcKee. I'll post out whenever we're going to do workshops or webinars and those type of things. And also you could follow Docker, right? So do at Docker, get all the news, latest, updates. And then also too, as you go through things and you're using Docker more and more for some of your workflows, and you wish that Docker had some feature that's missing, right? And I really, really hope you do this because we see a huge need and a huge advantage for using containers in your ML pipelines, right? And so go to our roadmap, which is on GitHub. The URL is right there, and I'll put these in the chat before we drop off here. But go to the roadmap. That's our public roadmap. That is the roadmap that we use, what we're working on. Our product managers are in there all the time. Our CEO is in there. So if there's a feature or something you would like to see in any one of our tools, put it on the roadmap. Search for maybe the feature's already there. Put an extra thumbs up on it. Put a comment in there. Get involved in the discussion around it. We would love that. But again, get into the Docker, our Slack community. That's probably the best. I'm in there. You can reach out to me, ask me any questions. Also reach out to Twitter on Twitter. Ping me. Twitter is very hard to kind of help with issues, right? You get, well, I don't know. It used to be 144. I forget how many characters, maybe 240 or something like that. A little hard to help someone on Twitter, but feel free to ping me anyways. But also on the Slack, that's probably one of the best places to find me. I will say that I will help with questions and help everybody out. It's a little hard to help people troubleshoot their specific environment and runtimes and those type of things. So just a little caveat, please don't get mad at me if I can't help you fully just using Slack. Sometimes it needs, second level support or something like that. Anyways, again, thanks everybody. I really, really appreciate it. and stay safe out there. Hope everybody's doing well in the world. Looking forward to hopefully when all these things pass that I can get back out there in the community. I'd love to get up in Toronto and around the world and see everybody and connect with everybody. But great, I really really appreciate it. Thanks so much again for showing up, and best of luck to you. And again, connect with me out on the interwebs. Thanks everybody.